Hi, this is Paul. We are doing Leetcode must-know interview questions. Today's challenge is to validate a binary search tree. Okay, rated as medium. I don't know. I mean, we kind of know how to work with binary search trees now, but okay. Well, there's a number of different ways to do this. One not so good way that we're not going to do, you could just check every node, and if the maximum value in the left subtree is smaller than the node, and if the minimum value in the right subtree is greater than the node, then you have a valid binary search tree. Now, you're going to have some helper functions like min value, max value, because when we were talking about like, well, what is the minimum value in the right subtree? We need a function to carry that out. Okay, well those functions, min value and max value, are going to be O of n. The process of visiting every node and applying those functions, I mean, visiting every node is also O of n, so the whole thing comes out to be O of n squared. So that isn't good. You know, just for validating a binary search tree, I mean, we know we can do an in-order traversal, so that's O of n, so that's going to be better. I mean, we can do an O of n, we can do an in-order traversal. We can, use an auxiliary array, do the in-order traversal, put the values in an array, and then see if they are in sorted order. If so, that's a valid binary search tree. We could keep track of the previous value as we're doing the in-order traversal. I guess that's going to be a little bit trickier, but we could do it. It's still going to be O of n, but we wouldn't have to use the extra array. We're going to try a third approach, or is it a fourth approach? Depends on how you count the in order. We have two ways of doing it with an in order traversal. But what we're going to do is we'll write a recursive helper function. And what that function is going to do is going to take as input a node, a min, and a min value and a max value. And it's going to check whether a subtree rooted at the given node is a binary search tree within a specified range of min and max values. So let's say for the left, maybe if we had a picture of a tree here. For the left subtree, we're going to call the helper function with the range where the min can be integer.min value, and the max can be node data, which in this case, we're talking about the root node 5, would be the root value minus 1. Okay, so we want a function that's going to tell us whether everything in the left subtree is between integer min value and 4, which it is. And then for the right subtree, we call it with min set to the root value plus 1. So everything in the right subtree should be between 6 and integer.max value. And you can see that, in fact, it isn't, that there are smaller values in the right subtree. So that's not a valid subtree. There's another one here that is a valid subtree, but it's just so simple that it's just silly. you know, start here and figure out if everything in the right, or I'm sorry, the left subtree, which is just one node, is less than 2, and everything in the right subtree, which is just one node, is greater than 2, which it is. All right. So as we do this, both of the recursive calls have to return true for the entire subtree to be a BST. The implementation of this is actually pretty simple. Let's look at the constraints here. The number of nodes. All right, so we're going to have at least one node and up to 10,000. The values, well, I guess we don't really care about the values, I don't think. All right, well, let's try an implementation here. So we have is valid BST, but as I said, we're going to have a recursive helper function, and we're going to return that. So we're going to say return is BST util, and what we're going to pass in there is the root node, and we're going to pass the min and max values. These will get updated within the is BST util, but when we pass them in, we're looking for values in between integer dot min value. I'm going to scoot this over so we can see it. Integer min value and, whoops, where'd it go? Integer min value and integer max max value. Okay, that's it. You scoot it over a little bit so it doesn't wrap. All right, now we'll write that method, and we'll say this could be a private method. Private Boolean BST util. All right, the input is a tree node. Let's just call it node. And int min and int max. Okay. If node equals null, return true. An empty tree is a valid binary search tree. All right. I guess, let me think about this. I'm trying to think if we need what I'm thinking of putting in here. Okay, yeah, we're gonna need that. Let me scoot this over a little bit so we can see why we need it. But all right, let's say if, wait, where's my cursor? Right here. If node node.val is less than min, or node.val is greater than max, return false. All right, why are we doing that? I mean, it's not possible for a value to fall outside of the range of integer min value and integer max value. Yeah, that's true. But when we call this recursively, we're going to change min and max. So for example, when we call isBSTUtil on the right subtree, we're going to change min to the node val plus 1. Now the node val at the root there is 5, so we're going to change min to 6. So we'll take any values over here in the right subtree as long as they are between 6 and max value. But the first node we come to is 4, and 4 is less than min. So we don't even have to do any more work at that point. We're done. It's not a valid tree. So we just kick out false. All right. Now, to finish this off, we need to do recursive calls on left trees and right subtrees. So we'll return what is this called? Return isBSTUtil node dot left. We can keep the min that we passed in, which is integer min val, and the max is going to be node val minus 1. Okay. So anything in the left subtree of any node is fine as long as it is between integer min value and the node value minus 1. I don't know, let's take a quick look at that. How does that work? Like, if we call it on the left subtree of 5, as long as this is between integer min value and 4, we're fine. So yeah, actually that node is fine. We wouldn't get this far because once we hit the 4, we're going to just stop the thing and return false, but it would work on this too. You know, you get down to 4 and you say, I'm going to call it on the left subtree. I will take any value between min value and 3. So yeah, 3 is good. So we've got that, and we've got a very similar operation on the right subtree. And that would be isBSTUtil node dot right. All right, so the min for a right subtree is going to be node val plus 1. Okay, everything's got to be bigger than the node val, and then we'll send in max as max value, and that should do it really. You know, these examples, the trees are very small and simple, but you know, I assume in the test cases that they're going to run it on trees that are much bigger and more complex. But it's you know, if you have a function that works, you can call it recursively on any tree that you want, and we should be okay. So let's try that. All right, so it's good on the basic cases. Submit. Wrong answer. Whoa, okay, hang on. Hang on. All right, I'm going to try to fix this on the fly because it looks like it's failing on like actual min value nodes. I think I can do this. I think I can do long min value, long max value. Let's submit it and see. Possible lossy conversion from long to int. Okay. Okay, and then if I do that, I would have to change these down here to be long. All right. Let's try and run that. Okay, that's accepted. Let's try and submit. Still the wrong answer. Huh. Okay. So that's the root, and it's the same. Okay. All right. I still think it is a problem with just edge cases where we're right on the where the input is coming in as min values or max values. And so if we do something like node val -1, but I could see that wrong answer that the node val was integer.min value. So what happens if you subtract 1 from integer.min value? I mean, I guess it's going to overflow, and I really don't know what it's going to do. But it's not going to do what we want it to do. So I'm adding casts here now. I'm going to cast the node values to longs. So we're going to do everything as longs. I mean, we can't change the definition of the tree node where the values are ints, but we can use min value, we can use the long min value, we can use the long max value. We can cast the int values to longs and then do them that way. So let's try and run this and see if it's going to compile first of all. All right, that's good. And okay, let's submit. Okay. Yeah, we're good now. So the errors were edge cases where it came back and said we passed 79 out of 85 test cases, but the one that they showed as wrong is one where it's just a 2-node tree. The root was -2 billion something. Basically, it was the integer min value, and the left child was the same number. So that's not a valid. It's not a valid binary search tree because the numbers are the same. But when we're trying to subtract 1 from the integer min value, I guess I don't know what it does exactly, but it's gonna roll over to something that we don't want. It's not actually going to subtract 1 as an int. It may just roll over to 1, in which case it would be a valid binary search tree. I mean, I'm going to research it after I sign off here and figure out, in fact, what it does, but that was the problem. It won't work if you try to do everything with ints. All right, so here is the solution. Very good runtime. And I hope you enjoyed it despite the mistakes. But I don't know, the mistakes were kind of educational in a way. I sort of thought about that before we started. Like, well, what if the tree has nodes that are max value or min value, but I mistakenly thought, nah, they wouldn't do that. Anyway, Yeah, I hope you enjoyed it. Feel free to like, subscribe, comment, and see you next time. Okay, I thought I might as well include this as a PS here. I just looked it up, but if you subtract one from the minimum value, Java will return the maximum integer value. So in that case, if you have a binary search tree where the root is the min value and the left child of the root is also the min value, yeah, you're going to subtract one, and the root is now going to be the max int value, and that will be a valid tree, and you will get the wrong answer. Similarly, if you try to add one to the minimum integer value, you will get if you add one to the max integer value, you will get the minimum integer value. Well, I didn't know that. But anyway, that's it, and see you next time.